In this video, we're going to look at adding addition and subtraction of rational expressions with unlike denominators. So before we get there, though, I want to take a look at an example that we've seen before and just kind of remind you of the concepts that are associated with that and how we're going to apply it similarly to the rational expressions. So if we have 3/8 and 1/4, we need a common denominator in order to add them. So when we look here, we see that our common denominator is 8. So we need to take 4 and multiply it by 2. And then if you multiply the denominator by 2, you need to multiply the numerator by 2. So then you have this 3/8 plus 2/8, which we could say is 3 plus 2 over 8, just to show you the long way of doing that. And we get that it's 5/8. So similarly, when we have 5 over x squared minus 4 plus 3 over x plus 2, we are going to need a common denominator. So first off, we want to take this x squared minus 4, and we notice that it is a difference of squares. So we can say it's the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. So we have 5 over x plus 2 times x minus 2 plus 3 over x plus 2. Now we look and we say, okay, we're going back to our least common multiple, or in this case our least common denominator. So we're looking for the least common multiple of x plus 2, x minus 2, and x plus 2. So when we think about that, we're like, okay, well, this one is missing an x minus 2, and this first one isn't missing anything. So we see then that our least common multiple, or our least common denominator in this case, is x plus 2 times x minus 2. Now in order to get there, we need to take and multiply this second one by x minus 2 over x minus 2, because it's a lot like over here when we were multiplying 3/8 and 1/4, getting a common denominator. We had to multiply by 2 over 2. So over here we're multiplying by x minus 2 over x minus 2, which is equivalent to 1, but it allows us to change it without changing the actual problem. So now we're going to put it all over the same denominator. So we have 5 plus 3 times x minus 2. Now some of you might be tempted to take and add the 5 and 3 together, but order of operations tells us we need to take and distribute the 3 first. So we get that this equals 5 plus 3x minus 6, and that's all over x plus 2, x minus 2. And then we can combine like terms of our 5 and minus 6, and so we have 3x minus 1, 5 minus 6 is negative 1, over x plus 2, x minus 2. And now we look and say, can we factor our numerator? No. Is our numerator exactly like one of the factors in our denominator? No. So we are done. And so there's your answer. So if this helps you at all, go ahead and like my video. You can take a look at some of the other ones that I have on my channel. And thank you for watching.